The first stage in making one of these new fibres is to come up with an idea for what kind of glass you need and what kind of pattern of holes, what kind of structure you want to put in with it. And you can do some modelling and brainstorming and come up with a concept and do the theory to test that out. The next stage is to really do it and see if it works. For us, that first stage is often making a glass. And if we were to do this just in open atmosphere, we'd have a lot of water getting into our glass, and that stops it transmitting light at certain wavelengths we're really interested in. So what we do is when we make a glass is we mix all of these chemicals together in a nitrogen atmosphere, which is very, very pure. The amount of water in there is less than 1 part per million. So you basically take a whole bunch of high purity chemicals and mix them together in a precise combination and heat them up until it becomes a molten glass. You then take that molten glass and pour it into a mould. And when that cools down, after it cools down in a very controlled fashion, you have what we call a billet of glass, which is just a uniform piece of glass with no structure within it, a few hundred grams in weight. Once we have that glass, we then extrude it to put structure in it. And we heat it up to the point where the glass just starts to become soft. So it's not molten, but just slightly tacky and soft. And we put up to 100 kilonewtons of force, so it's a big old squeeze. we push the glass through a die. That die is often made of something like stainless steel. And that die forces the glass to take certain patterns. And that could be a few holes, or it could be up to a few hundred holes. And what you get out at the end of that is something that might be 20 centimetres long with some pattern of holes, and those holes are on the scale of millimetres. They're quite large macroscopic features. The next stage for us then is to take this preform, which is what we call the big structure with these big holes, and we put it up in the optical fibre drawing tower. And the optical fibre drawing tower has a furnace which heats up the glass till it's almost molten. And then you then pull on the end of the fibre so you can stretch it and make it much smaller. And then these holes that were millimetre scale become micron scale. And the whole outer diameter of the fibre then becomes roughly the thickness of a human hair. And if you've done it right, and there's a lot of things that are involved in this, you've actually kept those little holes intact, but at a much smaller size. And then once we have the fibre, the next step is to take it into the optics labs, put laser light in it and test what the fibre does and see whether your crazy idea worked.